So the trophic levels can be shown in a pyramid. Here you have a lion, a rabbit, and a carrot. And here it says secondary consumers because they're second in the line of any organism that's a consumer. And then at the bottom you have producers, anything that can make its own food, any plant or phytoplankton if it's in the ocean, or algae if it's in a lake. All of these are producers. And they also belong to the first trophic level. Primary consumers are your herbivores. They're the ones that eat the plants or the producers. They belong in the second trophic level. And the third trophic level is where your secondary consumers like the lion occur. The producers are always at the bottom of the pyramid. And if you think about in nature, there's more producers, more plants, more leaves of grass, more algae in the whole world compared to us or other consumers. So they have the biggest piece of the pyramid, and that's why they're at the bottom. Primary and secondary consumers are less numbers of them, and you'll see why, because the energy that's passed from one level to the next is less at each level because it gets used by whatever is eating the previous organism. So the amount of energy decreases as you move up the pyramid. That's why the second piece is smaller than the first piece, and the third piece is smaller than the second piece. And that is why we use an energy pyramid instead of an energy square or an energy diamond, or etc. And it's also the reason that we have an upright triangle versus an inverted triangle where the point would be at the bottom. Make sense? Only about 10%, this is a very magic number that you have to remember, only about 10% of the energy is passed from one trophic level to the next. So from producers to primary consumers, only 10% is passed. From primary consumers to secondary consumers, only 10% of this energy is passed on. So there you have the arrows pointing at 10% and 10%. Remember that, 10% each time gets passed on. So one more thing, an example that I wanted to show you was let's put some numbers to this, okay? And this is not in your notes, but I just wanted to explain it because it's important for the activity that we're going to do in class. So let's say that we have in the producers, they're getting all the energy from the sun. So let's just pick an arbitrary number, just means a random number, to represent our units of energy. So let's say that the producers have 1,000 units of energy. Okay? How many of these units are going to get passed on to the primary consumers? Well, we know that it's only 10%. So what you do is you multiply that whatever number of units of energy you have times 0.1. Because 0.1 is the same as 10%, but we're changing it from percent to a decimal. So when you put that into your calculator, 1,000 times 0.1, let me use my calculator just to be exact, 1,000 times 0.1, which is the same as 10%, that gives me 100 units of energy. So 100 units of energy get passed to the primary consumers. And this is not always the same. This is because I started with this number 1,000 and I just picked it out of the blue because it's an easy number to work with. Okay, so now the primary consumers, they got only 100 out of the 1,000 initial units of energy. So then what happened to the other 900 units of energy? Well, the grass or the producer used it to make more grass, to make seeds, and some of it also gets used up by the rabbit. The rabbit jumps around, it runs away from predators, it has babies, so that's where these 900 units of energy are used. And also, some of the energy is lost, or not lost, but transformed into heat energy. Anytime you have a living organism, it releases heat out into the environment. So that's where those 900 units of energy went, and only 100 units of energy got passed. So then after the rabbit uses its energy, snap, it gets eaten by the lion. So how many of these 100 units of energy does the lion get? Well, we're going to have to multiply this number by 0.1 again. Because, again, that 0.1 is the same as 10%. So out of 100, let's see, I'm going to plug it into my calculator. 100 times 0.1, that gives me 10. The lion only gets 10 units of energy, and I've just put UOE. UOE stands for units of energy. So you see, out of these 100 units of energy, 90 of them got used by the bunny hopping around, making babies, eating stuff, and then the other 10 were what's passed on to the lion. And that is why we have less consumers that are able to be supported by those 1,000 units of energy from the producers. That's why you have a smaller number here and hence a smaller piece of that pyramid. And that also explains, because you only have 10 units of energy, you can only support a smaller amount of consumers in the top of that pyramid. And that's why our pyramid looks, or our energy looks like a pyramid, because you have less and less energy available, at each trophic level. Okay? So that also comes into play. For example, let's say that there's a big, humongous forest fire, or let's say that a bunch of the bunnies get a disease. If you decrease these numbers, that's going to affect the consumer at the end of the chain. If you change the number of producers, it's going to change the number of units of energy available. So if there's less units of energy, then there's also going to be less energy for the consumers, and even less for the secondary consumers. Now the opposite is true also. Let's say that there's an increase in the producers. I don't know, there's like a lot of rain that year. What's going to happen is that your producer's part is going to get bigger. So you're going to have more units of energy available. You're also going to have more herbivores, more primary consumers, and more secondary consumers. So you need to understand how each of these levels relates to each other and what any changes would do to each other level. So I might be repeating some of this stuff on the next slides, but if not, make sure you review it so that you understand it, because that's really the main juicy part of what you have to know for this objective, and they always test it on the tax. So let me continue to the next slide, which is a question. Which trophic level has the most energy? And I need to erase the board here, right, because I wrote on the board. So while you think about that question, let me do this. All right. Which trophic level has the most energy? You should have picked the first trophic level, which, if you remember from the previous slide, represents the producers down here at the bottom of the pyramid. Next question. How much energy is passed from one trophic level to the next? You should know that magic number. It is 10%. Or when you use the calculator, you can always use 0.1 or just 0.1, which is the same as 10%. Now you have a question, and I know you can't see it, so I'm going to read it out loud to you. It says, a food pyramid represents the relative amount of energy in trophic levels. Which of the following, that's my alarm, which of the following correctly shows a food pyramid? So the first answer choice says producers, herbivores, carnivores. Letter G says producers, carnivores, herbivores. Letter H says carnivores, herbivores, producers. And letter J says herbivores, carnivores, producers. So pick your answer, or you should already know. And the answer is letter H. That's the only one that's correctly showing that producers are on the bottom. Producers are always on the bottom. and then herbivores, and then carnivores. Next question. In this food pyramid, which level contains the greatest amount of energy? Is it tertiary consumers, secondary consumers, primary consumers, or producers? The triangle shows right here at the very tip, it says tertiary consumers. Here it says secondary consumers. Here it says primary consumers. And here it says producers. And the answer is D, the producers. Most of the energy goes to the producers because they get their energy directly from the sun. Now let's review the vocabulary very quickly. Make sure that you know the word before it comes out on the board, because if you don't, then that means that that's a word that you need to review and know it before the test. So pyramid, pirámide, having a broad base, this is the base, and sloping upward to a point. Its size decreases as it approaches the top. So that's just a description of a pyramid or a triangle. Tertiary, terciario. It's third in rank, order, importance, or value. Basically, this means third. You might also see the word tertiary, or you might see the word like this, a 3 with a little O at the top. That means tertiary or third. That's the same as when you write a 3 with an R and a D next to it. Tertiary. Producers, productores, organisms that make their own food through photosynthesis. Another word or a synonym for that is autotrophs. Herbivores, here's a picture of a cow. Heterotrophs that eat only plants. And I'm sorry, I didn't explain the picture before, but this is a picture of a fern, and it doesn't have seeds, it just has these little pores in the back. I forgot to explain this picture. This is a picture of a fern, and it doesn't have seeds, but it is a plant. All it has is little spores on the bottom, and they kind of look like they're gross little bugs on the bottom, but they're not really. So the word herbivores means heterotrophs, because a heterotroph is something that cannot make its own food. A heterotroph that eats only plants. Carnivores are heterotrophs that eat only other animals. Here's a picture of a lion. So that is the end of our food pyramids and energy pyramids. I hope you understood the main points, and I hope you took your notes and ready for the activity in class. Well then, we'll see you tomorrow.